Okay, so we come to a super important time in our quest for understanding organic chemistry. As I said before, the main question in organic chemistry is what are the electrons going to do? We have a very convenient notation, super helpful for your eyeballs, to show what the electrons are going to do. All right, and so we're going to use something called curved arrows, and we're going to use curly arrows. Some people call them curvy arrows, curly arrows, curved arrows, okay? And it's a curved arrow, and it's got a head and a tail, and the head is where the electrons are, and the tail is what is being attacked. Okay, so I borrowed the slide from our publisher, and the author of the slide says exactly what I would say. The sooner you master the skill, the easier the course is going to be. So an example might be here with this cation. We have some electrons, and you see this curved arrow here. The electrons, it looks like that double bond, that pi bond is going to come over here, which is what very similar to what we had in last section when we're talking about the allylic cation, where we had resonance, right? So we're going to use it a lot in resonance, but we're going to use it in other things too. So let's come over here and let's look at it with respect to let's look at some. Actually, there's two rules here which I want to probe before we get any further. We're never going to show a breaking of a bond when you're with an arrow like this. Okay, so this is not what you're going to see. You see a cation here, and what you're not going to do is get resonance by having a sigma bond come over here and go into the place of a pi bond. Not going to happen. Okay, now single bonds break, but not through resonance. Okay, now the next thing we're going to do, and this is very important to remember, we're never going to have more than 8 electrons in second row elements: boron, carbon, nitrogen, oxygen, fluorine. Never have more than 8 electrons. Okay, so if you have a structure like this, you might say, oh, I've got these extra electrons here. I bet you that I can bring them down. So you see the arrows already here, right? Bring them down here. But if I do, then it's going to make a double bond here, right? And then carbon's going to have 5 bonds or 10 electrons, which is no good. Not going to happen. Same thing here for nitrogen. If I bring these electrons here, boom. So far, I mean, the arrow is beautiful, right? So you go, oh, no problem. I'll just have a double bond here. Cannot have a double bond because that would give you, look at that, 10 electrons. All right. So now it's easier to see if I have the hydrogens on here, but it's difficult to see if I have this here. And this happens all the time. See, all the time. Students will bring that down, boom, put it there, and make a double bond and go, oh, no problem. But I would say, no, you can't do that because you can't forget that before with the line bond structures, before you did that, you had 2 hydrogens here, right? And so if we do that and have a double bond here, then this carbon is going to have 10 or 5 bonds, which is 10 electrons. So this is going to have to be something you're going to have to practice with and get your eyeballs used to. Okay. So we've seen that second row elements will never have more than 10 electrons, but occasionally they have less. So here's the structure of acetone. And this is actually a legitimate curved arrow. So you've got a pi electrons here. It is possible for these guys to come up here and make an anion, right? And if they do that, it's going to leave a carbocation in its wake. It does not have an octet, but this does happen. All right, so it's going to take a lot of practice, but we're going to practice it all the time. And I want you to pay special attention to every little mistake that you make and find out what kinds of misconceptions that you have that are going to come to surface when you draw bad arrows. I'll help you.